4 other things. So when you have like, so for example, carbon bound to even just 4 other hydrogens. So like methane, we drew that. All right, what you get is if you can picture that this hydrogen comes out toward you, okay? Because remember, molecules are 3-dimensional, so we're not talking about this one plane, uniform surface like this. We're talking about, so if these hydrogens are coming out of the board, and these ones behind it are kind of creating, you can kind of see this triangle. I should have inverted it, but like it. I can't do that with my hands, right? A triangle, so it's coming out of the board like this and like creating like a platform. Okay, so your hydrogens are in each of these corners of your triangle, and then the way that this is shaped then comes up, kind of looking like a prism, right? If you guys don't know what a tetrahedral is, kind of looking very prism shaped. And so if it makes 4 bonds like that, then it's shaped like a tetrahedral, which remember we talked about the fact that shape has a lot to do with bonding properties. So the way that molecules are shaped has a lot to do with the way that molecules will bind and how they'll act chemically. So if we look, okay, so I guess if we actually look at one plane then, so if we're not making 4 different bonds, so if it's a carbon double bound to a carbon, okay, these are all going to be in the same plane. And so no matter how I orient this, all right, so it's essentially, it's like saying, here's my plane, okay, and it's very much so square shaped, but it's square shaped, and so no matter how I orient it, it's still going to very much so be in this same plane. Does that make sense? Okay, kind of. She's talking about how it's going to bond, how it's going to act chemically. Shape has a huge influence over how molecules act chemically.